Okay, so this is problem 8 of chapter 21 of Giancoli 6th edition. So we have these two circular loops, the outer one and the smaller inner one. Through the outer one there is current going through. Okay, there is current because here we have a potential difference and we have this current going on. The circuit is closed. There is a resistance to the circuit. Okay? Now what we are going to do is we are going to move a little bit this wire here, this part of the loop, and we are going to increase, we are going to put it somewhere here. Okay? So we are going to increase the resistance. If we increase the resistance, what will happen to the current? We are not doing anything to the battery, right? So the battery is constant, the voltage is constant. We know that V is Ri. Since the R, the resistance is increasing, so we know that the current will be decreasing. And what is the consequence of this current that is decreasing to the inner loop? Okay, so we want to know what happens to the inner loop. What will be the current induced in the inner loop because of this change in the current of the outer loop. Okay, before going into this, first let's find out what is the direction of the magnetic field caused by this current in the outer loop. What is the direction of the magnetic field? Well, the direction of the magnetic field is coming out here. It's coming out here. On this right side is going into, but I don't care about what is going on the right side. No, I only care about what happens in the loop. So in the inner loop. So we are interested only in the inner loop. Okay? Alright, in that inner circular loop. So with respect to that inner loop, I know that the magnetic field is coming out. But my current of the outer loop is getting weaker and weaker. So that magnetic field that's coming out is getting weaker. Now, so we have this change in magnetic flux that will then will induce a current in the inner loop. And we want to find out in which direction this current will show up. Okay? So since it's coming out but is getting weaker, I want to help that. So we are going to create a current that goes also counterclockwise, no? Because then I can get more magnetic field coming out. Okay, coming out. So the answer for part A is the current induced current will be counterclockwise. Okay? Now you have to be careful with this problem because you may have a different one. Now in your case, instead of increasing the resistance, they may be decreasing the resistance, so it will be just the opposite. So be careful with that. Now the next question, part B, is what would be the direction of this induced current if the small loop was placed outside the larger one to the left. Okay, so I have the same big one there. Let's try to make this drawing again here. We have the same big loop here with the battery, with the resistance, with the current going all around, and my little loop is here on the left. So we want to know what would be the induced current in this little loop. Okay, so the scenario is still the same. The current here is decreasing. The current is decreasing because the resistance is increasing. Now this current here, what is the direction of the field of this current? What is the direction of the field created by this current with respect to the inner loop? Well, I know that the current is going, or the magnetic field is going into, right? Use your right hand. Since the current here is going down in the outer loop, then in the inner loop we have a magnetic field going into the page. Okay? Now this magnetic field that is going into the page is getting weaker and weaker. We are going to oppose this change and then create, induce this current that will help it and put more into the page. So we have for part B, our induced current has to be clockwise. So you see that changing the position of the loop changes the whole story.